Hello, I'm Elena, and this is Team Analytics Technical Presentation for CS6440. Our project involves the mapping of supplemental data that is sent to the CDC. We have been given 90 conditions that require this. A section of hepatitis is shown here as an example. Here are our project goals. The first goal is to map fire resources. From the earlier example, we could see basic data, the liver enzyme test data, and contact with sick persons. Listed are examples of how the resources and queries might be handled. The second goal is to maximize resource commonality between diseases. So that liver enzyme test, for example, might apply to multiple conditions. The third goal is to generate requests for supplemental information from an EICR notification.
As shown in the introduction slide, we need a set of disease-related fields that are needed for CDC notification. For the unmapped disease-related fields, we will search for similar fields in our fire resource. If an appropriate fire resource exists, then we will group the fields by resource type. If such resource does not exist, a new fire extension will be created to encapsulate the maximum number of unmapped fields. In the examples shown in the previous slide, for hepatitis disease, the liver enzyme test data could be grouped into one entry in the existing fire observation resource, while contact with sick person would require a new resource created by a fire extension. In general, our approach will be to leverage existing fire resources and fields for this mapping process. The mappings generated in the part 1 can be stored in a single fire resource, let's call it notifiable disease. Each disease would have its own entry containing all the data elements and queries to search for each data element. And we will automatically generate reply message in response to EICR for supplemental data. The source codes and scripts are available at the following GitHub URL. For the system, if there is a need to extend existing fire resource, we will use our own custom fire build for this project. We have already obtained a disease data which contains a list of data elements for various diseases such as hepatitis, and the dataset is already available in our GitHub repo. Regarding the tools, we're going to use Python language to code our scripts to perform the project-related goals listed earlier. And for the mapping task, we also plan to use existing unified modeling language tools.
Here is the architectural diagram of our project. The information provided to us from the CDC is stored as a series of CSVs. The user can feed one or more of these CSVs into our data parser, which processes the disease data into a format our app can use. From there, it will be passed to the translator, which leverages existing resources stored in our Fire server to pass back existing configurations that match the input data fields. For fields which don't currently exist in a resource and can't be mapped this way, our app will have a user interface that a developer can use to easily convert these fields into resource fields. From there, the new resource specification for the disease will be saved to our Fire database, where it can be leveraged by the CDC and other users. Here's the timeline on which we plan to develop this app. We've given ourselves 2 weeks to manually map an initial disease to a fire resource. We are starting with hepatitis. If useful or necessary, we may map a few others as well. From there, we'll take what we've mapped manually to create our Python app to translate other diseases to fire resources in the semi-automatic process described earlier. We've given ourselves 3 weeks to do this. Following that, we will have another 2 weeks reserved for testing and bug fixes. During this time, we will also pass the final iteration of our app along to our clients and make revisions as they deem necessary. Finally, we've given ourselves 5 days to deliver our final project and create our final presentation. Throughout this time, we have weekly meetings as a team and check-ins with our mentors as well.